Welcome to the wonderful world of ratio, proportion, and scale. Okay, so this is the PowerPoint that I used in school. So just in case you were absent or just wants to hear it again because you just love learning about ratio, proportion, and scale, here it is for your listening and learning pleasure. Okay, so basically a ratio is a comparison between two numbers or two values. For example, if there are 25 students, 10 boys, 15 girls, the ratio of boys to girls is 10 to 15. Now, please, as I told you in class, make sure that you read this carefully because most of the time, okay, we just do things blindly. And when that happens, okay, then mistakes, okay, careless mistakes happen. Okay, so boys to girls, so we're looking at 10 to 15, okay? So we can write it three ways, 10 is to 15 or 10 to 15 or 10 over 15. But at any rate, you still need to simplify, okay? So when you simplify, it becomes 2 is to 3. Why? Because the common factor of 10 and 5 and 15 is 5. So divided by 5 will give you 2 and 3, or 2 is to 3 or 2 over 3. Okay, so that is the basics of ratio. So let's do some practice. There are 24 pieces of fruit in a basket. Okay, now, 24 oranges. There are pieces of fruit in the basket, 24 oranges and 21 apples. What is the ratio of oranges to apples? Okay, so it needs to be orange first, apples next. So what would it be? Of course, very good. 24 is to 21 because oranges to apples. Okay, but this is not lowest terms yet. So the greatest common factor of 24 and 21 is 3. So divided by 3, and we end up with a simplified ratio of 8 is to 7. 8 orange, 7 apples. Okay, let's go to the next slide. So again, there are 12 pieces of fruit in the basket, 24 oranges and 21 apples. Now, if you did not read carefully, you would say, why is Miss Nass asking the same question? And I will tell you, no, I will not ask the same question. You have to read properly. And if you did read properly, now you will see I'm asking for the ratio of apples to oranges. So apples to oranges. So now it's 21 is to 24. Okay, and again, common factor is 3. So we have 7 is to 8. Always simplify. Miss, but it doesn't say simplify. It doesn't matter. It should be second nature, like breathing. Okay? Simplify. Okay? Always. Use proper units. Show your work. Even though it's not written there, it's a given already. Okay? So that's why it's 7 to 8. Okay? Now let's go to the next slide. There are 24 pieces of oranges and apples. Now it's asking for the ratio of apples to the pieces of fruit in the basket. So when they say pieces of fruit, it's referring to the total. Miss, the total is not given here. What do I do? What do I do? Simple. You know there are 24 oranges and 21 apples. And there are no other fruits in there. So what do? Just add the number of oranges to apples and you will get the total number of pieces of fruit in the basket. Mind blown. Okay, so 24 plus 21 equals 45. Okay, so now ratio of apples to the total number of pieces would be 21 is to 45. Okay? Because there are 21 apples and 45 pieces of fruit in the basket. Now, greatest common factor is 3. So this becomes 7 is to 15. Okay? So let's look at the next slide. It's getting trickier and trickier. Okay? Let me change the color of my pen. Now it's saying there are 72 pieces of fruit in the basket. So this is the total. And the ratio of apples to oranges is 4:5. So technically it's saying there are 4 apples and 5 oranges. So what is the total number of fruits in the basket if we are to follow this? 4 plus 5 equals 9. But Miss, it said it should be 72. This is only 9. There must be something wrong in the world. Well, remember, this is simplified. Okay? So, what you need to do is you need to find an equivalent ratio so that when you add them, it will total 72. Okay? So, there are many ways of doing this. I can keep on adding 4 and 5 together, okay, until I reach 72. Okay, let's see how that works out. So 4 plus 4 is 8. Okay, 4 plus 5 is 9. 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 So how many is this already? 9, 18, 27, 36. Not enough. So 4 plus 5 is 9. Now we have 45 pieces. Now we have 54 pieces. Now we have 63 pieces. And so this should do it. Now we have 72 pieces. So I had to add the ratio by itself 1, 2, 3, 4, 5, 6, 7, 8 times. Okay, so 8 times. So how many times did 4 come out? So 8 times 4, 32. 8 times 5, 40. So 32 plus 40 equals 72. 72 and 72. But that takes a little time. What if I say there was 7,200 fruits? Are you going to do that until you reach 7,200? Of course not! Because you don't have a paper that long. No, just kidding. It will take a long time. So what is a shortcut? We know that the ratio, if you add them, will give you the total number of fruits. However, this is the simplified already, simplified ratio. So how do we make it reach 72? Okay, so simplified ratio, get the total, and then divide the total number of fruits by the simplified total, which is 9. That will give you 8. So 8 is our magic factor. What's a factor again? It's the numbers that you multiply together. Very good. Okay, so let's take our simplified ratio and multiply it by the factor. Times 8 times 8. Okay, so you got 32 is to 40. Ta-da! It's the same. Okay, so this is the ratio of apples to oranges. So this is apples, this is oranges. So how many oranges are in the basket? 40 delicious, juicy, and sweet oranges. Lots of vitamin C, good for flu season. Okay, let's go to the next slide. Now, this is a similar problem. Okay, what color do I want to use next? Okay, so the ratio of boys to girls, so let's write it there. Boys to girls is 2:3. Okay, so if there are 200 students in year 8, how many boys are there? Again, boy to girl, this is the simplified ratio. So if we add that, the simplified total is 5. But it said there are 200 students. What are we going to do? Same. 200, the real total divided by the simplified total, which is 5, will give you 20, 0, bring down the other 0. 0 divided by 5 is 0. 0 times 5 is 0. So the answer is 40. 40 is our magic factor. Okay, so what are we going to do? We are multiplying the simple ratio by the magic factor, and you end up with 80 is to 120. And when you add them together, drum roll please, dig, 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 they total 200, which is the actual total. OMG, it's amazing. So now the question is, how many boys are there? And since this is the ratio, since you were very organized and you label everything, we know that there are 80 boys in year 8. Boom. There you go. Okay? Now, next slide. Now we're going to proportion. Okay? Now, what is proportion? Proportion is the equivalent ratio. Okay? Equivalent ratio. Okay? So when we increase or decrease something, okay, we are looking for equivalent ratio, which is like equivalent fractions. Okay? So we need to look for the factor or what will make things equal. So let's go through this step by step. What is the first question? Okay. What is the ratio of mix to water? Okay, of mix to water. So for 6 pancakes, let's put another label here. Ratio. Okay. Oops. It's not straight. It's killing my OCD. Okay. So ratio of mix to water for 6 pancakes, it's 1 is to 1.5. 1 cup to 1.5 cups. Okay. For 12, see what's happening here? How did we get from 6 to 12? We multiplied by 2. 6 times 2 is 12. So look what happened. 1 cup times 2 equals 2 cups. 1.5 cup times 2 equals 3 cups. So the new ratio for 12 pancakes is 2 is to 3. To get from 6 to 12, we multiply by 2. To get from this to this, times 2. This to this is times 2 as well. Okay? Now, from 6, how did we get to 18? So 6 times 3 equals 18. So what's happening now? 1 times 3, 3 cups. 1.5 times 3, 4.5 cups. Okay? So 3 is equal to 4.5. So what is the increasing factor for that one? Is 3. So we multiply everything by 3. Okay? So now, here is the tricky question. The box tells you how to make 6, 12, and 18. Why in the world do you want to make a weird number of pancakes? Why not just make 12 and put the 3 in the refrigerator, right? That would be the logical way. However, since we have to do a math problem, we had to make it that way, okay? But it's the same process, okay? So choose which one do you want to use. You can start with 6 or 12 or 18, it doesn't matter. But logically, which will make it easier to get to 15? I would choose 12, not only because it's close to 15, but if you look at the ratio, it is nice, made of nice whole numbers. 2 is to 3. Okay? So let's do it over here. So for 12 pancakes, the ratio is 2 cups of mix to 3 cups of water. Remember, ratios can still be written this way, okay? Now we want to make 15 pancakes. So, what will be the new ratio? First, we have to find the factor. How did 12 become 15? So, what did I multiply 12 with to give us 15? Let's make an algebraic equation. Let's say, okay, let's put a line there. 12, and since we don't know what the factor is, let's give it a variable, equals 15. So divided by 12, divided by 12, x is equal to 1 point what? x is equal to 1.25. Okay, so that is the factor. X times 12 times 1.25 gives us 15. So that means to make an equivalent ratio, we need to multiply this ratio of for 12 by 1.25, which is the factor, to give us, okay, 2.5 over 3.75. So if I want to make 15 pancakes, I need 2.5 cups of milk of mix to 3.75 cups of water. Okay? So let's do this now for 100. It's the same thing. Which one do you want to use? Okay? So for 15 cups, let's just put it here. We need 2.5 cups of mix and 3.75 cups of water. Now, if we want to make 100 cupcakes, which of these four are you going to use? Okay, logically, we do not want to use 15. Why? Because if you made a mistake here, then you will make the same mistake here. But if you use any one of these on top, then you have a chance that you can get a correct answer. Okay, so which one do you want to use? As I said, you can use any. Okay, so okay, why don't we use 6 this time? 6. Okay, so if we look here, to make 6 pancakes, I need 1 cup of mix to 1.5 cup of water. So we want 100 pancakes. Okay, so what do I multiply 6 with to get 100? Okay, so that would be 6x equals 100 divided by 6 divided by 6 would give us, so this should be 6. Okay, x is equal to 16.67, round off, okay? So that means 16.67 times 6 would give us roughly 100. So we multiply this by the same factor. So you end up with 16.67 cup of water, okay, times over 25 cups of water. So 16.67 mix and 25 cups of water. That is a lot. Okay? Okay, let's go to the next slide. Okay, this is another example of using ratio and proportion. Okay, so ammonia is a compound. Compound means a combination of 2 or more atoms consisting of a 1:3 ratio for nitrogen and hydrogen atoms. So this is nitrogen and this is hydrogen. Okay, so if a sample of ammonia contains 1,563 nitrogen atoms, how many atoms of hydrogen are present? Okay, so the simplified ratio is 1 nitrogen to 3 ammonia. Okay, so the new ratio is saying, so remember, this is nitrogen, this is hydrogen. Okay, so the new one is saying, what if there are 1,563 atoms of nitrogen? How much hydrogen will there be? Do you know? Of course not. That's the question. So what do we do when we don't know something? We give it a beautiful variable. Okay? Now, this is where we want to cross multiply. What is cross multiplication? It is what I call the X-Men strategy. So you multiply the numerator by the denominator of the other fraction on the other side of the equal sign, and you multiply, okay, that's supposed to look like an X, okay, but never mind. So this would be 1 times X, that's X is equal to 3 times 1,563. X is equal to 4,698. So that means If there's 1,563 atoms of nitrogen, there will be 4,698 atoms of hydrogen. Okay, so there are 4,698 atoms of hydrogen. Okay, now let's do this. This one is the opposite. It's now asking for, okay, how many nitrogen atoms are there if there are 1,425 hydrogen? Let's go back to the basic ratio. Nitrogen and hydrogen. So there's 1:3 ratio. Equals, now we do not know what nitrogen is. Let's give it an X. And we do know that there are 1,425 hydrogen atoms. So again, we do our cross multiplication. Okay, the process does not change. The numbers change, but the process doesn't change. So what do we have here? 1 times 1,425 is 1,425, and 3 times x. Isolate the variable. Over 3 over 3. So what's the answer? The answer is x is equal to 475. So that means there are 475 nitrogen atoms. Okay, so I think this should be the last one. Oh, no, not yet. Okay, the last, second to the last. So this is, now we are going to scale. Okay, scale just means we either enlarge, which means to make bigger, or reduce, which means to make tiny, tiny smaller. Okay, so what do? Well, you just have to measure, okay, one side or one dimension of the object and measure the corresponding area and dimension in the enlarged object. Okay, so let's say this is 10 cm and this is 30 cm. Okay, what is the scale factor? In other words, what did we multiply or divide, okay, to make this into this? Okay, so let's look at this one first. It's 10 centimeters. So what did I multiply? What did I multiply 10 centimeters by to get 30 cm? Okay, so let's see. 10x equals 30 divided by 10 divided by 10, x equals 3. So the factor is times 3. Okay, 10 times 3 is 30. So the factor is 1:3. For every 1 centimeter, okay, is equivalent to 3 centimeters here. Okay, and that's when we enlarge or make bigger. Okay, now what if it's the opposite way? Okay, what if I want to reduce? So if I want to go from here to here, what did I do to 30 to make it 10? So it would be 30x equals 10 divided by 30 divided by 30. X is equal to 1/3. So that means I had to divide 30 by 3. Okay, so in order to get from here to here, I needed to divide. So I flip this. So now the ratio is 3:1. That means for every 3 centimeters here, it's equivalent to 1 centimeter here. Okay, 3:1, big to small. 1:3, small to big. So this is what we call a reduction. Okay, to reduce, to make smaller, teeny tiny. Okay, so let's go finally to the last slide. Okay, so the ratio of length to width of a rectangle is 5:3. So remember, length is up and down. Okay, width is left and right. It's the wideness. Okay, So when we say the length is the width of a rectangle is 5:3. So this is length, this is width. Okay, so the length is bigger because it's 5 than the width. Okay, 5:3. Length is 5, width is 3. If the rectangle is 24 cm wide, okay, so the new rectangle is really big. Let's say this is not to scale, but let's say this is 24 cm wide, okay. What is the length? So what is the length? We don't know, so we give it an X, okay. So look at this one. The first proportion, 5:3, 5:3, length over width. So the same thing happens here. Length, X, width, 24. Do not flip it, okay? This is not correct. No, 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 no. Okay? Length, 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 width, width, width. Okay? And then we do our favorite X-Men. Cross multiplication. There you go. There you go. So you have 3x is equal to 5 times 24. 3x is equal to 120 divided by 3 divided by 3. X is equal to 40. Okay? So that means this is 40. Okay? What is the scale factor? Okay, so now you have 5/3, and now we know the new ratio is 40/24. What did we do to 5 to make it 40? What did we do to 3 to make it 24? So let's calculate 5x because we did not know, okay? What is the scale factor? Is equal to 40 divided by 5 divided by 5. X is equal to 8. So let's see. Multiply by 8, multiply by 8, and you can see 5 times 8 is 40, 3 times 8 is 24. So in this problem, the scale factor is 1 to 8. Okay, 1:8. That means for every whatever unit, 1 cm, okay, it's equivalent, it was enlarged by 8. Okay, because this is an enlargement. Okay, there you go. Hope you understand this. Bye-bye.